3.5 Operations Matrices. So this lesson's intro to matrices. So we're going to talk about what a matrix is, how to use it, and how to do different things, how to do other basics with it. So first, what is a matrix? A matrix is a rectangular array of numbers. That's it. Just any set of numbers that you put in like a little array like this, a little rectangular, and that is the matrix. It's just an easy way to view numbers, and it lets us do lots of things with them. So right here, you see right there, that's data organized in a matrix. There's more data organized in a matrix. It just lets you know really quickly what some data is. Like these are all the wages, those are all the sales, and lets you do lots of stuff with it. So it's just that's all matrix is, just a way to rearrange numbers. That's it. So look at this first example here. The table displays US Census data. So in A says organize data in a matrix. So all he wants to do is just write it as a little matrix array, like 7.1, 6.8, 3.2, 1.1, 6.6, 5.9, 2.2, and 1.4. That's my little matrix of this data. Now we should keep in mind what everything is. Like this is the ages 0 to 19 and 20 to 39, and this is male and female. Right, but that's all a matrix is. It's setting and making a set of data. Add the elements of the columns and interpret the results. So these are columns when you go down. Right, like I always think of columns like this, like if you're going to Greece or something. That's my bad example of that. And rows go this way. So they want you to add up all the columns. So they want to add all these down. So if I add them all up, 7.1 plus 6.8 plus 3.2 plus 1.1, 10, 12, that is going to be 18.2. Add up all these, 12, 1, 16.1, I believe. Could be a little off there. What does that tell us? Well, this tells us the total number of males and the total number of females in the United States in millions. Right, so that's all it is. Add the elements of the column, so we're going to add all these up, and then interpret the results. Well, this is the total number of males, total number of females, right? Because this is broken down by age. Males between 0 and 19, males between 20 and 39. If we add them all up, we just get all the males and all the females. So that's B. C wants to add elements and rows, so we want to add the rows together. So 7.1 plus 6.8, I get 13.7, get 12.7, add these up, I get 5.4 and 2.4. So when I add up the rows, I get this set of numbers. And you want to know what this is? Well, these are all the people between the certain ages, right? These are all the people between 0 and 19, all the people between 20 and 39, 40 and 59, and 60 plus. Right? So that's the total amount of people in each age group. And we call this in the matrix. Like, what's the benefit of the matrix? Well, the big benefit is if we have lots of data, we can put it in a calculator or in a computer. So you put in the matrix first and let the computer work on it. Would find the average of the rows or columns provide meaningful data. So if we find the average of these, would it do anything? Not really. Average male and female, like it wouldn't give us anything. In this case, it doesn't give us anything. So like that's just not going to give us anything. Is what it says up here. How when you analyze data that organize a matrix, sometimes you get results that you can interpret, sometimes you need further analysis, sometimes you get meaningless data. That's what that would be. That'd be meaningless data. Like average male and female is not going to do anything to me. So that's what a matrix is. Now let's talk about the basics of it. So first is the dimensions of a matrix. So that's saying how big a matrix is. If I give you a matrix like this, I want to be able to name it. So the way we name a matrix, we go row by column. So rows are the first ones, and then columns. So rows by columns, very important. So matrix I have right here, I have 2 rows, row 1, row 2, and I have 3 columns. So this is a 2 by 3 matrix. That's how we're going to name it, rows by columns. So let me do some quick other examples. Okay, this is something we could talk about. So this right here, if you look at it, you have 3 rows. Row 1, row 2, row 3, and only 1 column. So this would be a 3 by 1. On this side, the opposite way, you only have one row, but you have 4 columns. So this would be a 1 by 4. This right here is a special one. If you notice, it's row 1, row 2, column 1, column 2. This is a 2 by 2. It looks like a square, so we call this a square matrix. And we'll talk about more about those in later lessons. So anytime you have a matrix that's exactly the same row and column, we call that a square matrix because it looks like a square. Those have special properties. So that's the dimensions of a matrix. So next up, so how to add matrices. So adding matrices couldn't be any simpler. All you do is add up the corresponding parts. So see here you have you have this matrix plus this matrix. You're just gonna add every component in the first little portion right there, everything in the second column, everything in the third and fourth. That's it. Same thing with subtraction. You just add the like terms, add the corresponding parts. That's it. So if I give you 3140 plus 210 negative 3, all we're going to do is add the corresponding parts. 1 plus 1 is 2, 0 plus negative 3 is negative 3. So that's how you add and subtract. You just add and subtract the corresponding parts. Key thing though, they have to be the same dimensions. If I want you to add a matrix like this plus a matrix that doesn't match it, they can't be added because there's nothing to add this column to. So they have the exact same dimensions. You need to add the corresponding parts. They have to be able to correspond. And then multiply by a scalar. So first let's talk about what a scalar is. That's just a fancy word for number. That's it. So when we're talking about matrices, a scalar is just a number. So when they want you to multiply a matrix by a scalar, saying, hey, get this matrix and multiply by that number. And all we do there is distribute to every single element in the matrix. And that's it. So you have this negative 3 out here, you multiply by everything in the matrix. And that's how you multiply by a scalar. So let's do some quick examples. Number 2, we're going to add this matrix to that matrix. So again, they match. All we do is add the corresponding parts. There we go. And that's a matrix notation with the little brackets. So they add this 1 by 3 plus this 1 by 3 and I get that answer. Number 3, if you notice this one, if you add 9 to 12, 8 negative 8 to 2, but this guy, what does he add to? I can't. They don't match. So impossible. Or no solution. That's all it is. We'll do one more of these. So we'll do number 4. They want me to subtract these matrices. So a couple ways to do it. I think the way most people are going to do is just subtract. If you're going to subtract, don't forget to subtract everything. So I just rewrote it. So 7 minus 9 is negative 2. Negative 12 minus 6 is negative 18. 15 minus 4 is 11. And 4 minus negative 9 is positive 13. Double negative. You get that? Other way to do it if you wanted to is you could distribute the negative and just make it a positive. So it'd be like adding a negative matrix. So that's an alternate way of doing it. You just distribute the negative and then to add these two matrices together. Exact same answer. So that's how you add matrices. Just add the corresponding parts. Couldn't be simpler. We'll do one of these. It's the same idea. So in this case, I want to figure out what this is. So 4b minus 2a. So actually, we'll do this one by hand, and I'll show you how to do one of these on your calculator. So 4b. So I'm going to do 4 times the matrix b. I'm going to subtract off 2 times the matrix A. So all I got to do is simplify it, right? This distributes to everything. So I get 32, negative 4, negative 8, 28, minus distribute the 2 to everything. Now again, you can distribute the 2 or you can distribute the negative 2. Works either way. I'm actually going to do the negative 2. For me, it's a little easier. So I'm going to get a plus here instead. And multiply negative 2 times all of them. Now, since I distribute the negative, I'm just going to add these. So 32 plus negative 12 is 20. Negative 4 plus 8 is 4. Negative 8 plus negative 6 is 14. And 28 plus 10 is 38. There you go. Okay, now let me show how you do in the calculator. Actually, we'll do the exact same problem to see if I got the right answer. So first, the calculator. I gotta try to enter in matrix. So there's a little matrix button right here that's in blue. So we're gonna hit second matrix. And we get something that looks like this. Now, names is where you're gonna select your matrix. So when I actually have a matrix there, you could select it. So for now, we're not gonna do anything with it. If you go to math, that's where you actually do some operations on it. Like determinant, there's some other ones we're gonna use. You're gonna love that one. But let's go to edit. That's where you actually gotta type in your matrix. So this is the first step when we have a matrix. So I'm just gonna press enter. Then it asks me what type of matrix do I want. So in this case, let's do this prompt here. So I'm gonna plug in matrix A. Let me plug in A so I don't confuse myself. So for matrix A, I'm gonna plug this in. It's a 2x2 matrix. So you put 2x2. And then it draws a little 2x2 for you. And then you just enter in the values. 6, -4, 3, -5. So you have that. Now I also want to enter in matrix B, so let me go back to my matrix. And go. See now how matrix A is ready to be selected? I'm going to move over to edit and press matrix B. That's also a 2x2. So I'm entering those values. So 8, -1, -2, and 7. So now I have all my matrices entered in. I'm going to quit. Back to the home screen. I'm just going to type this thing in. So I'm at 4. Then select my matrix. Go to B. Then minus 2 times matrix A. So second matrix. And then select A. Hit enter. It gives the answer. 24, -14, 38. Same thing I got. I love when my math's correct. Anyway, so let's go into the last problem here. Gerardo, Olivia, and Nikki have 2 tests in their math class. The table shows their test grades for each student. Write a matrix for the information for each test. So, again, matrix is just an arrangement of numbers. So, 85, 75, 96, 72, 74, and 83. There's my matrix. I do want to keep in mind this is test 1, this is test 2, and this is Gerardo, Olivia, and Nikki. Find the sum of the scores from the 2 tests expressed. So, I'm going to add the 2 tests. So I'm going to get, I'm at 154, 149, and then 96. So it's 179. So those are sums of 2 tests. So that's how well they did on the test. And then C says, express the difference in scores from test 1 to test 2. So let me subtract test 2 from test 1. Okay. So 72 minus 82 is -13, -1, and -13. And that's all they want me to do. Now again, you could get information from this, like from this one right here, you could tell, oh, Nikki did the best. By how many points she did the best on also. You can see how well how worse people did from test 1 to test 2. Hey, at least Olivia was consistent. Right? So that's matrices. Basics.